This is an interesting probability one. We are asked to find the probability that if we randomly toss a marble into this figure, what's the probability that's going to end up in the shaded figure? Right, we have this little triangle up here, which is has base x plus 2 and height x. Right? And what we need to do is we need to figure out what the total area, what the probability is for it to land inside this area, given the total. Okay. Now, how do we do this? Well, we figure out what the total area of the shaded region is versus the total area of the figure itself, and then we set up a ratio. Right? So it's going to be area of the blue over area of the total. Okay. All right. So area of the total is the total base, this plus this, times the total height, which is that. Okay. So the area of the total is our x plus 2 plus our 4 over x times x plus 2. Let's put a little parentheses around that to make it a little more explicit what we're looking at, times our height, which is x plus 4. Again, we want parentheses around it because we need to multiply the whole height by our whole length. Okay, now can we simplify this? Well, we have an x plus 2 in each term, and since it's multiplying each term, we can pull it out. All right, so a t is equal to, and there's always these ones here, so we'll have a 1 left over in the first term plus 4 over x left over in the second term. We will have an x plus 2, which we have pulled out since it's multiplying everything, and an x plus 4 that we'll have pulled out. Well, that's just our height. Okay. Now, we want to simplify this a little bit, right? We have an x on the bottom, we have a 1 plus yada yada, and I like to have things that I can just kind of multiply in. Now what we can do is we can take our 1 and multiply it by an x over x, and that way we have a common base, right? We have a common base here, so we can have an x plus a 4, right? Let's throw in one more step here. The total area is going to be x plus 4 over our x, x plus 2, x plus 4. Okay, all right. So whatever we do, we're going to have an x on the bottom. We have an x plus 4 from this term, but we also have an x plus 4 from this term, and they're multiplied. So we can have an x plus 4 squared going on here. And our remaining term is x plus 2. And that is our total area. Next up, we need to figure out what the area of our blue area is. All right, so I'm going to figure out what the area of the blue area is by using the trapezoid rule. The trapezoid says it's the average of the one height and the other height. So it's x plus x plus 4 divided by 2. Right? That'll give us the average there times the base. The base is our 4 over x times x plus 2. All right. So, can we simplify this? Well, we have an x plus an x. When we're adding x's, we get 1x and 1x is 2x plus 4 over 2, right, times our 4 over x times x plus 2. All right. Now, can we simplify this? Yes. We have a 2, and 4 is 2 times 2. And so, to make it explicit, this is 2 times x plus 2 over 2, right? So that will cancel out with that, times 4 over x times x plus 2. Now, these are all multiplied, so we can multiply top to top, bottom to bottom. Well, we have 1's on the bottom here and 1's on the bottom here, so 1 times x times 1 gives us an x on the bottom of that. We're going to have 1, 4 that we're multiplying in, and we have x plus 2 times x plus 2, x plus 2 squared. All right, so that is our AB. This is our AT, and now we need to set up our ratio AB, the area, the blue area, over the total area. Okay, let's do that next. So the probability of the marble landing in the blue area is the area of the blue area over the area of the total area. So we're going to get this fraction, which is the area of the blue, the 4 times our x plus 2 squared over x, divided by the fraction of our total area, x plus 4 squared, x plus 2 over x. Okay, so we have a fraction on the bottom of another fraction. This is kind of messy. We can turn this into a multiplication if we flip this thing over. So this comes out to be this 4 times x plus 2 squared over x times this thing on the bottom flipped over. The x was on the bottom before, now it's going to be on the top. The x plus 4 squared was on the top before, so now it's going to be on the bottom. X plus 2, running out of room. Okay. Can this be simplified? Well, we have these x's on the top and the bottom. They'll cancel out, leaving the ones that are always multiplying these things. X plus 2, well, we got one of those on the bottom and two of those multiplied on the top. Since they're multiplied, we can take out a pair and cancel it out as a 1 over 1, leaving us with our final probability of 4 times x plus 2 over 1 times our x plus 4 squared. Now this can't be simplified anymore. The x plus 4 can't be broken into an x plus 2 without putting in extra additions. We can't cancel out anything where these have extra additions. So this thing is what we're stuck with.